Okay, 7.1. We're talking about graphing. First, we're going to just graph on a number line. We're going to graph inequalities on a number line. Reviewing. That is the basic review. Okay, so because graphing inequalities on the number line, the next step is graphing on the coordinate grid. We're reviewing this concept. So, less than negative 4. I don't require a lot of stuff on here. Okay, so as I was saying, I don't require you putting 0, negative 1, nothing. Just this, okay? Just put the one number on the number line. Now, with this, we're going to put an open dot. All right? And we're going this way. Because it's less than that number. Now, some people get confused and think, oh, well, wait a minute, negative 6, that's bigger than negative 4. Well, 6 is bigger than 4. But negative 6, even though you think about 6 being bigger, negative 6 is less than negative 4. And I always say take it back to money. Would you rather be in debt $4 or $6? I'd rather not be in debt, of course. But if you had to choose, you'd rather owe less money, $4. So that's a greater number. It's closer to the positive side. Negative 4 is closer to the positive than negative 6 is. So that's why it's greater. So, is negative 5 in the solution set? Is negative 5 left of this number? Yes. Is 8 less than negative 4? No. Is negative 4 in the solution set? Trick question here. No. Because it's less than, not less than or equals. This one throws people off. Here's what I see a lot of. Oh, 5. And that's a solid dot. That's easy. Oh, look, the arrow's pointing this way. That's wrong. Okay, that's wrong. Because if you read it, 5 has to be greater than A, which means A is less than 5. So, a lot of people will say it's better to write it this way. Always have your letter on the left. That way you can read how we read left to right. And when we read left to right this way, A is less than or equal to 5. Which still means a solid dot, but going that direction. Okay? Remember, the mouth always eats the bigger number. And it doesn't matter whether the mouth is, a crocodile, or Pac-Man, or Ms. Pac-Man. Doesn't matter. The mouth eats the bigger number. The arrow points to the smaller number. Now, if you always put your letter on the left, then you can do the shortcut and say the way the arrow points is the way the arrow goes in the graph. But that's only when the letter is on the left. So, is 4 in the solution set? Is 4 less than 5? Yes, it is. Is 5, careful, less than or equal to itself? Yes, it is. Notice the difference between these two. Okay? 4 is not less than itself, but 5 is less than or equal to 5. 8, is that less than 5? No, it is not. Okay, so recall, this is also a review. We do not, or we don't include the boundary in our solution set, which is shown by an open circle. That's for these two. Less than or greater than, we don't include the boundaries. We don't include that number, so we use an open circle. If it's got the line underneath it, the equal line, we do include the boundary in our solution set, which is shown by a closed circle. So open dot, closed dot.
What's that?
Closed.
Oh, okay.
Do. We do. Do. Okay. So. Okay. Again, this is review. But now we're taking it to the coordinate grid. And notice, these are equations. So listen, what we're doing here is we're reviewing two concepts.
Got it.
We're reviewing inequalities on a line. Now we're reviewing equations on a grid. And then we're going to go to inequalities on the grid. We're going to blend the two concepts together. So, y equals 5. Remember, y equals is a horizontal line. Okay? We just talked about this. Going through 5. So 1, 2, 3, 4, 5. We put a horizontal line right there. X equals -3 is a vertical line. That vertical line is going through -1, -2, -3 right here. Y is equal to 5x minus 4. We begin at -4 and we move 5 over 1. And this is positive, so I'm going to have an uphill line. And yes, put these reminders on there. So, -4. 1, 2, 3, 4. 1, 2, 3, 4. I can count. There we go. -4. And then we're going to go up 5, right 1. Up 5, right 1. And get that line sort of right there. Okay? 2 and 3 both go into 6. Cover-up method. If I cover that up, meaning, and I would do this right away, if I cover up the x, I highly suggest you do this because some of you are starting to get confused on this. And so are my Algebra 2 kids. I just do this. If you cover up the x, immediately you're putting a 0 for x. Okay? Now we're just solving. And no, we're not saying it's -3. That's what everybody keeps saying. What's y? -3. No, -3 is the coefficient of y. We want to find out what it is when we solve. And if we divide by -3, it's not equal to 2, it's equal to -2. Okay, because a positive divided by a negative is negative. So, -2 is right here on the y-axis. Now, if I move this over and cover up that, well, what am I doing? I'm covering up the y, which means I'm putting a 0 in the y position to make it go away. And if I do that, I get a 3 for x. Well, where's that? 1, 2, 3. And now I connect the dots. -1/3 x. Well, what's my b? It's not written, but it's 0. So we write +0 in our notes because, well, it's a reminder. That means I'm going through the origin. I have a negative slope, which reminder is going to look like that. Put a little arrow there to remind yourself. Negative slope is going downhill. So I'm going to go down 1, right 3. Down 1, right 3. Or I can go up 1, left 3, up 1, left 3, and get a line that looks like that. Again, check my name. It's going downhill. It's negative. Hey, 4 and 2 both go into 12. I know there's negatives, but just generally, they're factors. So I can use the cover-up method. I cover up the 4. Immediately, I put a 0 for x. I'm sorry, my bad. I covered up the x, so I put a 0 there. Now I divide. -12 divided by 2 is -6. That's my y. So I'm going to drop down here. 1, 2, 3, 4, 5, 6. Put a 6 dot right there. I'm going to cover up the y now. When I do that, I'm putting a 0 in for y. -12 divided by -4 is +3. So 1, 2, 3, and I draw my line through there. So, for equations, this is very important. For equations, the solution set is represented by only those points on the line. All caps, people. On the line. Shout in text. It's on the line. Okay, so look up here. Is that point in the solution set? No. Is that point in the solution set?
No.
This one?
Nope.
This one?
Nope.
This one?
Nope.
This one?
Nope.
How about that one?
Yep.
Yeah. How about that one?
Yep.
Yeah. If it's on the line, it's a solution. Okay? If it's off the line, it's not a solution. Okay. Now, like I said, I gave you a preview. We're putting it all together. We're going to graph inequalities. Okay. Step 1, plot a few points on the line by the appropriate method, whether it's cover up, slope intercept, whatever. Decide whether the points on the boundary line are solutions before connecting the points. This is very important, people. Listen. If we're using a less than or greater than sign, we're going to use a dotted line. You will lose points if you use a solid line for this. If we use less than or greater than, we use a solid line, which is corresponding to the idea of the open dot, closed dot. So remember, these are open dots and these are closed dots. Tie those two together. Open dots like a dotted line, closed dots a solid line because it's filled in. Step 3, find which side of the line the solution set or the shaded region by testing a point that is not on the line. You can't test the line because we want to know about the entire area. If the test point makes it true, then shade the side of the line that includes the point. If you test the point and you get a false statement, you shade the side of the line that does not include the point. That does not include the point. So let's do what we just did and put it all together. This one has a beginning at -2 and m of 1/3, which is a positive slope. So I'm going to go down to -2 and put a dot. I'm going to go up 1, right 3. 1, 2, 3. I'm going to go down 1, 1, 2, 3. Okay, now, technically, I will not take off of this. Technically, since this is less than, this is greater than, technically, I should put an open dot on all these, not a solid dot. Because, remember, I told you, dotted lines are for open dots, solid lines for solid dots. So technically, and I will not take off of this, because honestly, I did this for probably 18 years teaching this stuff, and they go, every teacher I've ever seen do it, just put solid dots, and then put the dotted line, does this. And then does a dotted line through it. And I was like, it finally dawned on me one day, I'm like, wait a minute, that doesn't make sense. If it's a dotted line, it should be open dots. Not a big deal, if you actually put solid dots, I'm not going to mark it off, but I'm just telling you for your knowledge, it should be an open dot. Now, I am going to put a dotted line because it's not, here's another clue. If it has a line underneath it, draw a line. If it doesn't have a line, it's dotted. Now here's what happens. You'll forget, I screw up. I draw a solid line like this. And after I'm done, I'm like, oh shoot. Okay, if you're using pencil, even better. Because all you have to do now is take your eraser and just erase part of it and make your own dotted line. You don't have to erase the whole thing and draw a dotted line, just erase part of it. It's going to happen. I do it all the time. I get ahead of myself drawing, oh shoot, it's dotted. It happens. Don't worry about it. You're human, it's going to happen. Now, we're going to pick a point. I'm going to tell you the best point in the world to use. 0, 0. I didn't have to tell you anything. Because it makes everything go bye-bye. Okay? So I'm going to test 0, 0. Watch what happens. This is so easy. 0 goes in for y. 0 makes this go bye-bye. I'm left with that statement. Is 0 greater than -2?
Yes.
Is 0 greater than every negative number out there?
Yes.
Yes, it is. So now, here's how it goes. I tested this point right here, and it was true. If that's true, so is this, and this, and this, and this, and this, and this, and this. So what you have to do is put it down at every point. No. You just go like this. Just have the grass grow up from the ground. Just throw some weeds up there. Okay? Just throw them up there like that. You do not have to do this.
Yeah, she said if it's not 8, so
Okay? So you just generally, because eventually we're going to be doing more than one, and if you shade the whole thing and then shade the whole, it's hard to see. It's good to use different colored pencils for this, but generally what I'm saying is if you just do lines like that, it's much easier. And that's it. Now, if I would have tested 0, 0, and you got a false statement, like this was a greater than sign, less than sign, I test here, it's a lie, so is every other point a lie, I would shade down here. Okay. So, here's another hint. No. Here's another hint. When you see greater than, right up above it, I would just do something like that. You know, something to remind you. And before you even start doing it, just to remind yourself. Dotted line, solid line. I'm not talking about the direction of the line. I'm just saying a reminder. Before you dive into it, to remind yourself which one's dotted, which one's solid. Okay? Now, what we're doing is we're pretending we're graphing this line, x equals 5. And again, that's why we reviewed this stuff in first semester. Because x equals 5 is 1, 2, 3, 1, 2, 3, 4, 5. It's right there. But instead of jumping ahead like I just started to do, I almost started to draw a solid line, I go and just do a dotted line. Like so. That's it. Now, again, I want to pick a point. Now, really you don't have to test the point here because vertical and horizontal lines are easy. Greater than 5. Is that going to be left or right? Right. Yeah. That's it. For horizontal and vertical lines, it's easy. Above a horizontal is greater, below is negative. For vertical, greater than is right, less than is left. Y less than or equal to -2. So we're pretending that we're graphing this line, y equals -2, which is down here, right there at -2. And I can go ahead and draw a straight line, solid line. Now, less than is just below. Good enough. Now, I'm not saying you don't have to do that. If you just want to do like a squiggle like that, that's fine. We're just not spending our time coloring. This is not adult coloring. This is just graphing. Okay, 1fx plus 1. I'm going to begin at 1. Technically, I should put a solid on open now, but if you don't, I don't care. It's okay. Move that. Ooh, there you go. Okay, now my slope is 1/2. That's my m. M is 1/2, which means I'm going to go up 1, right 2. Up 1, right 2. Down 1, left 2. Down 1, left 2. And I'm going to put a dotted line right through there. Now, the only point you can't use 0, 0 is when it goes through the origin. This is going through 1. I'm going to test 0, 0. It's the easiest math point to test. So I'm going to plug it in. 0 is greater than 1.
No.
No, it isn't. So therefore, where's 0, 0? It's right there. So I shade away. I'm going to shade it this way. Very good. Okay. Now, before we move on, I forgot about this part. I apologize. Listen up. It says circle the points that are solutions. Is 6, 0 a solution? Yeah, it is. Is 5, 4 a solution on the dotted line? It is not. If it was a solid line, it would be. Is -3, 2 over here? No. Is 12 -15? Was it down here? Is 12 right of 5? Yeah, it is. 6, 0 up here? No. 5, 4 up there? No. -3, -2. Yes, because it is less than or equal to that, so that's okay. 12, negative 15. Yeah, it's way below negative 2. Okay, this one, 6, 0, which is over here. 0, 1. No, because we don't have a less than or equal. 0, 0. That was our test point. 12, negative 15. No. It's all no. Moving on. We're beginning at negative 2. Right here. I'm going down 3, right 1. I can go up 3, left 1. I usually try to do more points, but you get the idea. There's my line. It's a solid line. I'm going to test 0, 0 again because it's easiest. 0 is less than or equal to negative 2. True or false? That is a false statement. Therefore,
We have to shade away from it.
I'm going to shade this way. Is 0, negative 2 a solution? Yes, it is, because it's less than or equal to it. Is 5, 4 a solution?
No.
Negative 8, negative 2.
No.
Yeah, that's because I got it here somewhere. 0, negative 15. Down here somewhere. Yes, it is. 0, negative 15 will be a yes. Okay, I did want to talk about this one. This means plus 0, right? Okay, remember there's no b, so it's 0, which means it goes to the origin. So we're going to start here, and we're going to go up 4, right 1. 1, 2, 3, 4, right 1. Down 4, 1, 2, 3, 4, left 1. Now we're going to get a line that looks something like that. That was horrible. Okay. Can I test 0, 0? I cannot. So something easy, like 1, 1. So 1 is less than 4 times 1.
False.
1 is less than 4. True. Okay? So the point 1, 1, which is right there, is true, which means I'm going to shade over that way. Now, this would be a dotted line. So, what do? I make my dotted line because I made a mistake. And I was just going to keep that mistake right now because it says test 0, 0. Well, if it was a solid line, 0, 0 would be an answer. But it's not. 5, 0 is, because it's out here. Negative 3, positive 2?
No.
No. 12, negative 15? Yes.
So it's like,
Okay, 6 is a really easy one because if you think about y equals x, don't draw this. That's y equals x. So y equals negative x is that line right there. And it is a solid line because it's less than or equal. Again, I cannot test 0, 0. So I'm going to test 1, 1. 1 is greater than or equal to negative 1. Well, that's a true statement, correct? 1 is greater than a negative number. So 1, 1 is true. All that's true. Now, since it goes through the origin and it's solid, like the last question, it is true. False, false, true. Okay, we're only going to do one of these. We're going to do number 8. Same time. So, I can do the cover-up method on this one. So I covered up y. X is negative 4. Okay? Cover up. Oopsie, that was not supposed to happen. Let's try this again. I'm going to cover up this one, which means I'm putting a 0 in for x, and y is negative 8. Right there. It's greater than, so it's going to be a dotted line, like so. Okay? Name 2 ordered pairs that are solutions. And so, first off, we've got to test 0, 0. So, if I plug in 0, 0, I'm going to get 0. 0 is greater than 16. Well, that's a false statement. So it's over here. So when I say name two coordinate solutions, anything over here, like, you know, -10, 0. Okay? -5, -8. Something like that. If I want to do non-solutions, well, obviously 0, 0 is an obvious no, because I tested that one. And then anything up in here, so, you know, 5, 7, whatever. That's it.